I'm Justin Erickson. I'm a program manager in the SQL Server Engine team. I work on high availability. I've worked on failover clustering, database mirroring, and now work on AlwaysOn, which we'll go through today. Just to give you guys a little bit of a warning here, this is a demo-heavy session on pre-release bits from about a month ago, so hopefully I won't have to give you too much of a tour of here are the bugs that existed from before. But please bear with me as I try to jump around and correct things. There's a couple bugs that I know will likely prop up. I'll see if I can work around them to make it a little bit smoother. We'll go through some of that. So this session, how many of you guys saw part one of the AlwaysOn session that Santosh gave? Okay, great. So I can go over some of the initial pieces there a little bit quicker. So this session will be basically taking the concepts that were introduced in that part one and going through each one of them and building up a topology from an existing deployment using each one of these concepts. So I'll do a quick recap for a couple of you that are new from what exactly is AlwaysOn, what are we trying to target with this. We'll go with an upgrade from a previous topology to the new topology, talk about the benefits that you get from that, and how to go and add and extend additional configurations there, including connection experience, adding multiple secondaries, quorum configuration. We'll go a little bit deeper into the active secondaries, and then I'll walk through a disaster recovery scenario using the new topology to talk through how exactly we manage quorum and how we do forced failovers there. Feel free to jump in and ask questions. I'll sort of gauge time, and as we start falling behind, I'll sort of defer some of the questions to the end. I will have these demos in the SQL Server mission critical booth. So if there are things that you want to be able to go into in more detail that I didn't cover here, I'm more than happy to do that. I should be there pretty much all day today. So quick look back. Today, what are people able to do with SQL Server and high availability? We have a number of customers running their most mission critical applications on SQL Server today. Including bwin, ServiceU, Care Group. If you go to the SQL Server cat.com site, customeradvisoryteam.com site, you can see white papers where they go in more detail, and there was also a session yesterday where each of these customers talked about their deployments there. But as we looked at what they were able to achieve, there were a lot of work that had to be done into how to go and put together the different technologies to meet the needs that they have today. So about 2 years ago, we took a holistic view of what's going on in high availability. And we wanted to look into a couple things. One was, where can we make the solution able to meet higher sets of SLAs that weren't possible before? So let's look at the complete sets of pain points, and particularly with how to go and keep the system up and running more. And then we also looked internally to see how can we make sure that we're building the right thing so we can go and adapt and extend this to take advantage of future trends and technology alignment going forward. So as we looked into Denali, you kind of see a couple different pillars here. Of course, the top one is I want to be able to meet the mission critical SLAs with whatever high availability topology that I have. And how can we make the SLAs even higher than what were before? Providing an integrated solution. So instead of a series of technologies that you could put together to build a solution, how do we provide that end-to-end solution that gives you what you need right out of the box? And gives you the flexibility to be able to choose, because everybody's deployment and SLAs are slightly different. And so giving the flexibility to be able to choose what sorts of technologies do I want to use where and what are the SLAs that I need. And then efficiency as well. When I'm investing in multiple redundant copies of very large pieces of hardware, how can I take better advantage of those than having them sit there completely idle until and unless the event of an actual disaster? So we look at mission critical SLAs. For those of you not familiar, RPO and RTO, recovery point objective, which is how much data am I willing to lose, and recovery time objective, which is how fast do I need to be able to recover from a failure. We looked at planned and unplanned downtime. Looked at local HA and disaster recovery, as they're very related, but also very different pieces there. Mentioned on the integrated, looking at a unified, simplified solution. So as we add in additional flexibility, one of the key things that we looked at from the beginning is how do we make sure that this new flexibility doesn't just mean a whole new sets of challenges, that we go and invest equally in our management experience to make it even easier than it was before, despite putting that, the additional capabilities in there. Flexible reusing existing investments. So the internals of AlwaysOn availability groups is heavily based on database mirroring. In fact, the same architect for database mirroring architected availability groups to take a lot of the concepts and lessons that we've learned, both from building the software as well as from your experiences, from conferences and from talking with CSS to make it a rich solution. Flexible in being able to take advantage of SAN versus DAS environments when and where you would like to go and use them. And efficiency, looking into hardware utilization through readable secondaries and backup on secondaries. So when we look at always-on availability groups, how exactly does this provide and what are the capabilities here? I know this is a bit of a repeat for a bunch of you, so I'm going to jump through this a little bit quicker. Feel free to stop me if you have questions. So when we look at flexible, availability group defines a set of databases, user databases that can fail over together. Allows you to be able to choose multiple replicas, multiple locations where these sets of databases can be. We provide up to 4 secondaries, 2 of which could be synchronous secondaries, and up to one of which can be my automatic failover target. Along with the flexibility, you don't have to have any of them be automatic failover, any of them be synchronous. If you would like to have 4 asynchronous copies, that's perfectly fine as well. Automatic manual failover, flexible failover policy, being able to choose what kinds of conditions do you want to trigger failures on. And automatic page repair, having the system have the ability to go and leverage the redundant copies of the data from your replicas. If you hit a page corruption from the secondary, be able to grab the data from the secondary and repair the primary seamlessly under the cover. So it's exactly like database mirroring if you've seen automatic page repair demos for database mirroring. Look at an integrated solution. As we're failing over and the topology is now getting a little bit more complex with having up multiple secondaries, how do we go and make sure that the changes in the awareness to the application don't need to increase with that complexity? So the application failover using virtual name is a great way of doing this, where we take a virtualized name associated with the availability group. So when the application is failing over, the client connection string doesn't need to change. It connects to this abstract virtual name that moves along with that availability group. The configuration wizard and dashboard are the key pieces where we look into the investments to see that as we add the additional flexibility that the system doesn't get more complex. So the configuration wizard I'll walk through and how we do the deployments. We'll connect to the multiple instances and guide you in your initial configuration, or it can just be used to be able to script out your configuration and do things later. The dashboard gives an all-up view of an availability group across all the instances, telling me when things are looking healthy and when things that I need to look in a little bit more deeply. So it gives me that nice aggregated view. For those of you familiar with database mirroring, you could see this as a the next generation of database mirroring monitor. System center integration. So as we look at the surface area for always on, we want to make sure that there's a rich T-SQL experience, a rich PowerShell experience, a rich SSMS experience, as well as a system center experience. The system center experience isn't quite yet available, so I won't be able to demo that today. But we are making sure that the things that are available in the dashboard and the things that are available through our management interface are getting bubbled up through System Center to give you that whole data center view of what's going on in your application. Rich diagnostic infrastructure, being able to go and diagnose issues as and when they occur. Adding file stream replication and replication publisher failover. I'm sure there'll be a couple questions about, hey, what about the distributor? Unfortunately, that is not something we were able to fit into the Denali release. When we look at efficiency, the ability to go and do read from the secondaries and backups from the secondaries. So now that hardware is not sitting there completely idle, I can actually go and offload workload to that to give more system resources to my primary workload and take advantage of the secondary systems. Yes? Mm-hmm. So the question is, quick question on the automatic page repair, does it self-sense or do you actually need to go run something? No, it just happens transparently under the covers. So let's look at what a topology could look like today. Let's say you have 2 data centers today where you're using database mirroring for your local availability and using log shipping for your disaster recovery. So in your primary data center, you'll have your 3 servers over here if you're using automatic failover. We'll call in the topology that I'll have over here, we'll call the primary one always on server 2. The mirror over here will be always on server 3. The log shipping secondary will be always on server 4. And then we'll have the mirror, the witness, which will be always on server 5. So this would be, imagine a common topology for people using DAS storage, and having high availability as well as disaster recovery. So we'll start with this topology, and we'll be able to migrate it over to AlwaysOn, and then we'll talk about what are the benefits that you get over there, and we'll go extend it to take advantage of some of the additional functionality that AlwaysOn provides you. Switch over to my demo machine now. So you see I've pre-configured, I have the 5 servers, so this is my primary. You see the principal and their synchronized databases. This is my secondary over here. You can see it's mirrored. We can see the log shipping secondary. And we see server 5 right now is just sitting there with nothing. He's my witness. So first thing I'm going to do, I'm going to let the topology continue to run while I go install clustering. So I've actually gone, there's 2 steps to installing clustering. One is I go to each one of the machines and I add the feature clustering. What this does is it just unpacks the bits. It doesn't actually do any configuration. So we'll see the actual steps of installing a cluster. So I'm going to go to create cluster over here. I'll add in each one of the server names. So I put in the primary, the secondary. I'll put in the log shipping secondary. I'm going to put in the witness as well. I'm going to give my cluster a name. This is just a management endpoint. It's not used internally for anything. It's going through making sure that name's not in use. And that's it. I go and press next. It's going to go across all the machines and stitch together my cluster for me. As you see in this topology, since I'm using AlwaysOn availability groups and I've chosen not to take advantage of failover cluster instances, I'm not configuring any shared storage configurations over here. So these are just plain old SQL Server installs that I've had up and running for days at this point. And now at some later point I said, now it's time for me to move up to AlwaysOn. And so I've gone and installed this. Of course, I'm running the latest Denali bits. So if you were running previous versions, you'd first do the rolling upgrades for database mirroring and log shipping, exactly the way that they've been done before, upgrading the passive, then going to the primary. But once I'm running Denali, at some later point, I chose to go and install the cluster. So now I have a cluster installed. I have all my SQL servers installed. My next step is how to give SQL. I need to give SQL Server the access to the cluster to be able to do the changes that it needs to go and do. And so I do that through Configuration Manager. On the properties, you see an AlwaysOn Availability Groups tab. I say Enable AlwaysOn Availability Groups. When I press OK, it's going to give me a warning that says, OK, at your time of your convenience, restart this instance. And then once it restarts, all the logistics of how it interacts with the cluster will be set up. And you'll see the rest of my configuration experience will be through SSMS and T-SQL. I'm actually going to cancel out of this, and I'm going to run a PowerShell script that does exactly the same thing. But it'll just do it across the different machines, so you don't have to watch me connect to each one and do the same steps. So you see it'll connect to server 2. It's going and basically checking that box and restarting each one of the instances for me. So I'll give this a couple minutes for it to finish. So the key thing here is I had plain old SQL servers installed for a while. My topology's been up and running, and I can choose at the later point to go install clustering. If I had a failover cluster instance, I would have already had the Windows cluster installed underneath it. I would have added in my additional nodes into that same cluster, gone through the same process here. One of the key abstractions to think of is failover cluster instance provides that instance level protection. An availability group will provide a collection of databases and give protection at that. So an availability group can live on top of either my standalone instances that I'm demoing today, or they can live across failover cluster instances as well. And it just works at a higher abstraction than that. So we're up to server 4 over here. So let's see what's going on in topology. I'm going to go refresh these guys over here. And unfortunately, I didn't have it restart agent in the script, so I'm going to start agent myself over here so log shipping continues to work. See where I am. Okay, so it's on the last server over there. Sure. Failover groups require Windows clustering, but do not require SQL Server failover cluster instances. So it's a little bit of a difference from before. Before, when you thought of failover clustering, you thought of the full stack. I'd go to Windows, I'd install the cluster, I go and create my shared storage, and then I go install this specialized SQL server that knows how to take advantage of clustering. For availability groups, you need the Windows cluster underneath. That's what we use for the distributed state and internode health detection. But you do not need to install the specialized SQL Server failover clustering installation. You just install plain old SQL servers that works with that, or you can choose to take advantage of failover clustering, typically for high availability. Does that make sense? Okay, so now I have my topology up and running over here. Let's open up some demo apps and see what they do. So I have 2 demo apps over here. These are connecting to database mirroring. You see I'm using the latest snack provider. I'm connecting directly to the server. I specify the failover partner over here, and it's telling me where my primary is. So I have both these guys. So I'm connecting to the database 1 and database 2. And you see that this just works. It's saying that it's connected to the primary over here. We'll take a look and confirm that his primary is still the primary after the restarts over here. So my first step is going to be, I have all the topology up and running. Since they're all based, database mirroring, log shipping, as well as availability groups is based on physical replication. I don't need to go and reseed the databases after I go and set this up. So my first step over here is I'm going to take down database mirroring. So I'll go to each one of the databases individually. I'll go to mirroring. Actually, before I do that, let me actually stop log shipping so I don't have to go and chase logs around. So I'll disable the log shipping job. What I'm doing here is I'm preventing the next log truncation from happening. I could continue to run, but then as I stop database mirroring, any of the log backups that would occur, I'd have to reapply onto the secondary side before I continue. So I'll stop that. Now I'll go over to the mirror. I'm going to remove mirroring. So I did that for AlwaysOn DB1. Do that for AlwaysOn DB2. We give an AG name. I select my 2 databases that make up my application. Whoops. So I'm going to add both of them in. I'm going to choose both of them to have automatic failover, to have the same capabilities as before. I'm going to allow them for read access for later in the demo when I want to add that in. So I put both of them to say allow read access. I'm going to give it a listener name. Since I don't snapshot my, domain controller, I'm going to just put a random number after it. So you'll actually see this will change in the next CTP to actually give an even better experience here. But I have 2 options here. I can say this is a small system or this is a test system. I'm going to allow the wizard to go through and do the backup and restore. Since I've already had database mirroring and I already have that secondary copy, I'm going to skip data synchronization here and say I already have, let's say this was a terabyte database, I already have that mirrored copy from before. So I'm going to use that to join in. I have a choice of saying I could script this out, so I could use the wizard just to give me that template, and then I can go take a look at and edit as I need. Or in my case, I'm just going to let the wizard go ahead and finish. So we'll take a look at what it's doing. So it went and configured the endpoints for me, or confirmed that the endpoints were already created. Since I was using database mirroring, I'm using the same endpoints. Created the availability group on the primary side. Right now, it's going through the process of creating the listener, that virtualized name that I will eventually use to connect my application to. And we'll see that the old connection strings actually will continue to work as long as I have a database mirroring parity configuration, meaning 2 copies of data without the readable secondaries installed. So the wizard went through and created successfully. So at this point, I now have my primary set up. I have the AG information available on my secondary. Oops. Let's go over here. So I can see that the AG information is over here. But the databases are still sitting there. The little pause button says they're either not joined or they're not synchronizing. And the reason is I haven't joined them yet. So I'm going to go use the wizard to go and say, just join in the databases that existed for mirroring. Use those to go and see them. So you see I didn't have to do any backup and restore across the different topology. You can imagine that if you scripted this, this would be a much faster process. So let's see what's going on in my system. So I'm going to use the dashboard. So now the dashboard's saying everything looks good. I have my primary server 2, my secondary server 3. All the databases are synchronizing or synchronized as I expect them to be. So now I have taken my database mirroring topology, moved database mirroring to be on always-on availability groups, and I have the databases now failing over together rather than independently. Let's take a look at my application. So my application, if I go and press refresh on these two guys, they're still able to connect. So my old clients didn't need to do any changes. If I want to take advantage of the fact that we now have that abstraction, I can go change this guy to say I'm going to use AG1. What did I call it? I call it listener 5. Didn't type anything wrong. And I can get rid of the failover partner. You'll see as I refresh this guy, he'll still stay connected. And I'll do the same thing for that secondary database. So now I've upgraded to database mirroring to always-on availability groups. I upgraded my clients to now connect to the AG listener 5. And now when I add in multiple secondaries, my client strings don't need to change. One other thing that I'm also going to note is we have a new keyword that we added in that you don't have to have, as you see over here. But there's a multi-subnet. Failover equals true. What this says is in case, and typically in my disaster recovery topologies, I'll go across 2 subnets. This will tell the clients that, hey, this virtual name may have multiple IPs associated with it, and so try them in parallel to maximize my failover time. If I was using legacy clients that didn't have the new keyword available, I could just change the connection timeout, increase that to allow it to be able to try the connection serially. So I don't have to use the latest clients, but if I use the latest clients, I get a faster failover experience. Even though I'm in one subnet, I'm going to put this keyword on. I think it's generally a good idea if you're connecting to virtual network names to always put the keyword there. So if you extend into multiple subnets, at the later point, you don't have to go around and update all your clients. So now let's go take a look at moving log shipping into always-on availability groups. Sure. So SKU hasn't actually been decided yet. My guess is a bunch of these features will be enterprise and above. I'm not sure exactly where that's going to end up. So what I'm going to do first is I want to make sure that the last of my log shipping backups have been applied onto the secondary. So I'm going to go through on the secondary side. I'm going to do the copy job. And here's where we're going to start getting into a couple of places where hopefully we won't have to do a tour of the bugs that existed a month ago, but we'll keep an eye out for that. Okay, so I just did the copy job. I'm going to do the restore job. Make sure I have the tail of the log. And of course, I could have upgraded both database mirroring and log shipping at the same time if I wanted to, but I chose to do it in steps so we could see the changes in the connection strings. Okay, so now I have my log shipping secondary should have all the last transaction logs applied onto it. I already disabled the job on the primary over here. I would typically go and actually tear down log shipping, but just to save time, I'm not going to do that since I know it's not going to restore anything useful right now. I'll go to the add replica wizard. This is just connecting to see what does everybody look like. I'll add in my replica, so I'm going to add in server 4, which is my log shipping guy. Now that I'm using always-on availability groups, before I had that asynchronous sets of jobs that were not even doing the continuous asynchronous syncing, I can choose a higher protection level. So I'm going to use high safety to give myself synchronous, an additional synchronous secondary. Since I also still have the databases over there in restoring state, I'm going to skip initial data synchronization and just continue to use my log shipping databases. And of course, I can script it out, but I'm going to go and press finish here and have it go and do it for me. So now I have the replica defined, but I haven't joined the databases in. So I'm going to go over here. I see the databases are still in the restoring state. Hope that I don't run into one of the bugs. Great. And I'll do the same for this other database. We have we'll probably see one or two of the bugs in a bit, but there's a bug that was a simple merge issue that we had from before that sometimes causes the secondaries not to recognize the LSNs. It's been fixed since then. But luckily we didn't run into it. So now let's take a look at the dashboard. And now we see my log shipping guys there as well. So I see always on server 2, 3, 4, and I see all the sets of databases, everything synchronized. Now I have one solution where I had database mirroring and log shipping before. I'm now able to use continuous replication across multiple secondaries over here. So now I've taken database mirroring and log shipping, and we can see, actually we're a little bit behind, so I won't go through too much of this, but I added in that secondary. My client connection string doesn't need to change since I'm connecting to that virtual name. So as I failed over to any of these guys, the clients will transparently connect, and I won't have to go and update clients based on backend topology changes. I'm running a little bit behind, so I'll speed up a bit, and if there are some questions here, I'll defer some of those to the end. So a couple things. Now we have the topology set up. One of the questions that we get a bunch is, okay, how does quorum work? What happened with that witness? And we'll go through some of those steps here. So first I want to talk about a couple of the prereqs that I'd recommend for any of these topologies. I actually don't mention it here, that all this requires Windows Server 2008 and above. There's a lot of huge enhancements in clustering that, both in usability and reliability in 2008 and above, that even if we support 2003, I probably wouldn't recommend it. We have two sets of features that, as we've taken and extending Windows clustering to do a little bit more than it did before. There's two QFEs that we recommend installing on all machines. And the deck will be available with the numbers here. The first one enables better support with failover cluster instances and always-on availability groups. I can go into more detail if any of you have specific questions on this, but essentially what it does is it allows you to have shared storage that's available to a subset of the nodes. So imagine I have a disaster recovery topology where I have shared disks that are only available in my local data center, and my other data center either has a different set of shared disks or is using a standalone instance. This QFE allows that to go and happen within the Windows cluster in a better way than it could before. And the second one allows us to configure quorum votes. So I can set up multiple machines and configure which machines are part of the cluster but don't impact quorum. And I'll go through a demo of that in the next slide. All nodes should be in the same AD domain. And then setting up the Windows cluster, you need a domain account, administrator on all machines, have ability to create computer objects and read all property rights in AD. There's a detailed article about how, if your user doesn't have those permissions, how to go through and pre-create those objects and have the cluster go and take advantage of those. I won't go into the details in this talk, though. So when we look at quorum configuration, the way quorum works is you need a majority of votes to operate and avoid split brain. Split brain meaning when I have two primaries that are running at the same time and independently serving different clients, thinking that there's nobody else running over there. Yes? It does take, if you're talking about, does it take advantage of something similar to Exchange DAGs? Yeah, this is very similar in how the quorum works between always-on availability groups and DAGs. We just have the ability now to go and configure votes, which I'd imagine Exchange, I've been chatting with them as well, will likely take advantage of some of that going forward. At the end of the talk, I'm going to actually go through a disaster recovery scenario, and I'll walk through how we go and prevent the split brain there. Okay. So when we look at how we set up quorum, it's basically a two-step process. One is we need to select which nodes we need to vote, and then the next one is we select the quorum type. So when we're selecting which nodes should vote, general guidance is if you put one vote for any node that's currently hosting the primary, or an automatic failover target at that time, and 0 votes for the rest of the nodes. As the rest of the nodes aren't able to go and participate in automatic failover, you don't want the system to go and say, when that node's gone, I'm degrading my SLAs. Once I do that, then I select my quorum type. So if I only have one primary, no automatic failover, I have an odd number of machines since I have one, and then I just select node majority. If I have an even number of machines, which I have in my topology over here, since I have server 2 and server 3, I have two choices here now that I'm taking advantage of the Windows cluster. I can add in an additional witness node and use node majority, which is similar to what database mirroring would have done, or I can use node and file share majority. So I can say I'm going to use these nodes, and I'm going to use some other protected file share resource to be my tiebreaker. Either one is perfectly fine, depending on what I feel more comfortable with providing there. The good thing with the witness here is the witness machine doesn't even need to have SQL installed on it, since it just needs to be part of that Windows cluster. And I'd recommend every time you fail over outside of the automatic set, you want to reevaluate and adjust your quorum settings, because now you could be running on a node that has 0 votes. And so other machines going down will now impact that one guy from coming up online. So let's go through our configuration that we just constructed over here and decide how we're going to set up quorum. So I have server 2 and server 3 are my primary. So I have the 2 votes that I want to go and configure, and I want to configure the rest with 0 votes. As I have 2 votes, I need to make a choice on how I'm going to configure my quorum settings. So I'll first go and configure it with a witness, and then I'll convert to using file share to show you both options. I actually have a set of scripts to make it a little bit easier. So this is a PowerShell script that sets the node weight. So you can see over here it goes through, and it'll set 2 and 3 to have 1 vote each. I'm setting server 4 to have 0 votes. And my server 5, which was my witness in database mirroring, I'm going to continue to use my witness, and then we'll have it printed out and tell us what it just did. So we'll do primary witness first. So it comes through, and it just went and configured. So I have my 3 votes over here with the 5 being my witness. Now let's say I decide I don't want to use the witness machine. I have a file share, and I might as well go and use that. So I'm going to use the cluster manager, configure quorum settings. I'm going to choose node and file share majority. I'll find a location for it. See what folders we have over here. And I have a folder conveniently created for me. So I just added in a file share. So now you see it says it's using node and file share majority. I'm going to now change the votes. Since I'm using the file share, I just need my 2 votes for the primary. So I'll have, So now I'll set server 2 and server 3 to each have a vote, and the file share is going to be my tiebreaker. I won't show it here since we're running a bit behind, but there's a DMV that we have within SQL Server that will, it's called sysdm cluster members. It'll tell me which machines have, which nodes have what votes, so I can see this from T-SQL as well. Any questions on that? Okay. So let's take a look at our new topology over here. So before I had a whole bunch of stuff going on with database mirroring and log shipping and managing across those things. Now, our new topology, I have server 2 and server 3 as my automatic failover targets within my primary data center. Server 4 as my disaster recovery site with synchronous mirroring between them. And I have a file share as my witness and tiebreaker over here. So I basically have exactly the same topology that I had before, all rolled up in one solution. But what do we get from this? One is we got better SLAs. So now we have multiple no data loss secondaries, which wasn't possible before. I have better data loss protection for DR secondaries through continuous replication. So even if I used asynchronous mode, I would still have a continuous stream of data rather than a periodic log backup. So even the asynchronous is faster. I get faster failover to DR secondaries now that I'm able to use the virtual name to fail over. I also get the advantage of when I fail over to that secondary, it's built on a similar technology database, meaning that I don't need to reseed like I would have had to do with log shipping. In addition to the better SLAs that I just transparently got from upgrading, is I got easier deployment and management. I have a unified solution, so I don't have to go and understand how the database mirroring and log shipping work. I just understand how always-on availability groups works. I have a simple deployment. You saw how easy it was to go and set up those initial things. For those of you who were at Santosha's talk, you saw that the wizard guided you through and created an initial deployment for you. I have the unified dashboard that tells me here's what's going on across my system. I'm not showing the rich diagnostics here, but the dashboard has a bunch of rich diagnostics, similar to database mirroring monitor that shows me across the entire system. I have centralized management of client topology, so that virtual name now abstracted. I added in that additional secondary, and I didn't need to go and change all my clients to say I'm deeply aware of what's going on the back end. And I have multi-DB failover. So my application had 2 databases. I can now put them together in an availability group so they move together as a unit. And this is what I got without making any changes. Let's say, yes. For the initial setup, so let's say you're saying when I don't have database mirroring or log shipping, I'm trying to do it from a large site. Yeah, so it's exactly the same concept as database mirroring. So the question is, how do I get the data to create an initial configuration with a large data set using AlwaysOn? So you just need to have that secondary site at the time that I press that join availability group. It should have a full backup of the data. So it obviously needs the data, and it needs a last taken transaction log applied to it. So a common way of doing that is setting up log shipping and then switching it over. For smaller data sets, you see the wizard can do it for you, but I mean, if you're doing terabytes of data, you don't want SMS to go and do a terabyte backup, copy it over the wire for you. But for large data sets, that's what you do. Yes? The question is, how is the data being copied over the wire? So it uses exactly the same concepts as database mirroring, where it's shipping the log blocks across the wire. It has compression built in to be able to optimize a bit for the amount of data that it sends. The nice thing here is if you're using something like SAN replication or other block level replication, those will typically replicate, not typically, they have to replicate both the log and the data pages. So you're actually sending twice the amount of data over. With this, we're just sending the log blocks over at a time, one at a time. It will already be compressed as we send it over the wire. If you have more questions, I can go into a lot more detail after the talk. Okay, let's say I've been running for a while. So I just took my topology, upgraded to Denali. I switched from database mirroring and log shipping to AlwaysOn availability groups to take advantage of the better SLAs and easier management and deployment. So I've been running for a while, and I start seeing that, my business is becoming more of a 24/7 business. My backup that I'm taking on that primary site in the middle of the night, which used to be okay, now is actually starting to impact my users in a different part of the world or some reports that are going on. How can I go and take advantage of the backup on secondary feature to keep that primary system just there for the primary OLTP workload? So we'll go into backup on secondaries to show you that. So this is where we are likely to run into a couple issues over here, but hopefully we continue to get a little lucky with the in development build over here. My notes. So let's take a look at backup on secondary has a couple features that are coming in a little later, but I can show you a couple of the previews here in terms of what is the T-SQL syntax going to look like. So first choice I get is, where is my automatic backup preference? And you have three choices. I can say I want my backups to generally be taken from the primary. I always want it to be taken from the secondary. Or I generally want it to be taken from the secondary, but the secondary is down, the primary is okay. So I'm going to choose and say I'm going to do secondary only. Then I get to choose for each one of the replicas, what is my backup priority? So I'm going to choose and say I want to have the backup typically taken from my mirror. If my mirror is down, I want it to take it from where that DR site was. And if that guy's down, then I'll take it from the primary system on AlwaysOn server 2. And so we have this internal function that that log shipping and our backup jobs will take advantage of that tells me, am I the preferred replica? So right now I'm connected to the primary. When I run this, it's going to say, no, you're not the preferred replica. I know somebody else who has a higher priority than you is online currently. And so the backup job that I would have scheduled would have aborted out at this point and said, I'm going to let that other guy go and take the backup. So now let me reconnect over to server 3. And I'm going to go and run that same thing again. Comes back and says, yep, you're the preferred replica. I know that nobody else higher than you is online right now. So there are two types of backups that we have. I can do full copy-only backups, and I can do transaction log backups. And when we do the transaction log backups, we coordinate to make sure the log chain is not broken. So I'm going to take a backup of both database 1 and database 2, copy only, and copy it off to one of my shares. Due to a bug right now, which will be fixed, I actually need to go and connect back to the primary to just run a couple transactions to move the transaction log ahead. So add in a couple rows onto the primary and the secondary. Now let me connect back over to the secondary. So I'm back over to server 3, and I'm going to do the log backup over here. Typically, I wouldn't have to go and half that running workload there. It's just an old build that has that issue there. So I'll now take the log backups over here. So you see that the secondary side is now taking all the backups for me. I could have scheduled my maintenance jobs here. If I wanted to continue to use log shipping for, I don't know, having a delayed apply or having an additional secondary somewhere else, I can have the log shipping running from this side over here, so I can log shipping not impacting my primary system whatsoever. Yes? Partner PM of mine, Kevin Farley, is talking to Data Protection Manager. I'm actually not 100% sure where they are right now, but if you come by the booth and ask for Kevin Farley, he can go into more detail on that. Okay, so that's as easy as backup on secondary is. It's actually built into the wizard as well, so when I'm running a backup, I can show you that real quick over here. So let's go to one of the databases and go and say tasks. I'm connecting on the secondary side. I get a wizard over here, a little warning over here that says, hey, this backup type isn't currently supported. Select a supported backup type. Eventually, I'll actually have an article over there. But basically what it's saying is I didn't do copy only. Once I select copy only, it says everything's OK. I can go to transaction log, and it'll say, OK, that's OK as well. And differential is going to give me that warning over there. So what did I get from the backup capabilities? I can make backups from any replica now. Synchronous or asynchronous, both fine. Primary backups still work. And log backups can be done on all replicas, and we'll maintain a single log chain across that topology. I'll show you the recovery advisor in a second, but the recovery advisor is a great tool that you go and point it to a bunch of folders. It goes and looks at what's going on and says, here's where I can restore you to. So giving you a very nice way of the system helping you figure out what you actually need to go and restore to get that system up and running. And we'll show that in a second as I seed another secondary. A couple of the restrictions, cautions, and gotchas that we talked through. Differential backups are not supported on the secondary. Only copy, only full backups are supported on secondaries. This is because we're not clearing that differential map over here. And it's advisable for the backups to generally be stored centrally, because now I'm taking backups on multiple locations. If one of those secondaries goes down, I still need to maintain that log chain, so I need some way to make sure that if I was running on server 3 for a while, taking backups there, and that guy crashes, and then I continue my backups on server 4, that I'm able to get the backups that server 3 took to have that full backup chain. So if you have using Data Protection Manager or one of these other tools to have those things stored centrally, it's a good idea, but not required. Let's say I've been running for a while now, so I have my backups off, and I have taken advantage of those other SLAs, and now I say, you know what, I have a bunch of these read workloads that don't need to be running on my primary. They're just doing a bunch of reports that I want to offload off to the secondary side. Let's see how I go and do that. And let's say I actually want to go and use the backups that I just took to seed a new secondary to go and create that reporting workload, offload that reporting. So I'll come back over to the primary system over here. Actually, you know what? We're running a bit late, so I'm not going to see the new secondary. I'll just keep the existing topology here, but I could have gone through. I'll actually show you the recovery advisor wizard, and then we'll skip actually adding the database in. Otherwise, we're not going to get through full stuff. So this is how the recovery advisor works. I'm going to go and choose where did I put my backup. So I'm just going to give it a folder location. It's Hadron Server 1, backup, BOS share. This has been fixed, but it didn't put in the transaction log before. It goes through and says, here are all the backups that I found within that location. I can add in a couple folders if I wanted to. It looked through and said, hey, you have backups for both DB1 and DB2. I can choose either one of them. Had I been taking a long series of backups, it'll give me a nice timeline of when were all the backups taken, where can I restore you up to. Since I just took the two right next to each other, I get this one thing over here. But this is a great wizard as it goes and analyzes everything across my system and tells me, here's what I need to do to get you back up to any of these points in time. So I'm going to skip over doing that, and we'll go just into taking advantage of the demo app. So I added in some data before, so I'll show you that the data shows up in my primary app. Let's go open a new application. This is going to be my read application. So the first thing I can do is I can connect directly to one of the secondaries. Actually, you know what? I'm going to go and skip over that. So I could always connect to one of the secondaries, and I have this application intent equals read only. So this is telling the system that, hey, my application is read only. So when I set that setting before that said only allow read only, it would allow me to connect in. I'm going to jump into taking advantage of what we call read only routing, which this allows me to specify connect to that VNN. Here, if you're specify that read only intent, I'm going to try to redirect you to one of my secondaries. So I've set it up to go and say, here's the read only routing for server 4, and I'll actually have to skip over server 5 since I didn't add it in. So I'm going to set up a read only routing for server 4. So this is telling the primary system, when you get a read only intent, here's the connection string for server 4. I'll delete this guy. Let's put this as server 3. And I'll switch this to server 3. So I'm just giving it the endpoint for redirecting to server 3 as well. And this is where you see the bigger thing happen. So I'm going through and saying, when I'm running as server 2 on the primary system, here's the read-only routing list. First, try to redirect to that server 4, and then try to redirect to server 3. So I'll go and run that. Now you see if I come in with this application, I'm connecting to that AG listener 5. I specify my application intent equals read only. Whoops, already misspelled something. Should I misspelled something over here? Have the connection string here as well. I must have misspelled. Okay, so let's go back up here, and I'll switch to listener 5. There we go. And so you see the application intent equals read only. You see that I'm connecting to that same listener that my primary workload's connected to, AG1 listener 5. I still keep in that multi-subnet failover to give me the fast connection. And I specify the application intent equals read only, and now I connected to the primary. The primary said, hey, you're a read only app. I have a preference that I can send you somewhere else. And it just sent me over to server 4 over here. If server 4 goes down and crashes and I try to reconnect, it'll connect to the primary. Primary will say, okay, server 4 is not there. I'm going to redirect you to server 3, since that was my next order in preference. Jump back over to here. So now you see I was able to take my backups, throw them off to another site. I could have seeded another secondary using those backups. By taking advantage of read-only routing, I was able to specify, here's where I want my secondary workloads to go. So now I've not only taken the backups that used to impact my primary system and thrown them off, I've actually taken sets of workload and taken them off the primary. So I can get better utilization for that primary workload on that primary system. Let's go through what exactly is read-only routing, readable secondary doing. I'm going to go through this actually fairly quick to see if we can get a little bit of the DR demo in here. So key thing here is even if I'm synchronous with readable secondaries, we are synchronously hardening the data to make sure your data is protected, but acknowledging the commit as soon as that data is hardened and not waiting for that redo that happens asynchronously afterwards. The idea here is we want to give you the maximum performance that you can get for that primary system rather than waiting for the full redo to be done and throttling that primary system further. So when you're looking at a secondary workload that's good to put off that secondary side, this isn't meant really for a full-on read scale because you're going to see different views of the data when you look at the primary versus secondary and actually between different sets of secondary. But it's great for something that needs to be near real time where minutes behind is okay for me to go and deal with. So reports are an ideal target for readable secondaries. So the redo thread, we've gone through. If we just allowed you to go and read whatever you wanted on the secondary side, the redo thread would have been getting blocked by the read workloads. So the solution that we have is we mapped each one of the isolation levels to snapshot isolation, which allows us to make sure that redo can continuously go and not get impacted by the fact that I have reports running onto that secondary side. And we'll never choose redo as a deadlock victim. I'll skip over this fairly quickly, but the idea here is we did some optimizations to how we handle row versioning. That if I enable readable secondary and I need a row version, on the primary side, we'll add those additional bits into the column, and we'll create the row version only on the secondary side. If I was doing enable readable secondaries and had recommitted snapshot isolation on the primary, it'll get created on both sides over here. Bit of an optimization. Any of you are interested in the details, come see me afterwards, and I'll go into more detail here. DDL reporting workload. I'll actually skip over this piece over here. So this just talks about how the redo thread can actually impact the reporting workload from running. So we make sure we optimize for the redo thread to be able to run as fast as it can, but the vice versa is not always true. Query parent performance. So another question when I'm looking at the readable secondaries over here. Doesn't the data needs to be physically consistent? How do I handle the fact that statistics can be different on my read workloads versus my primary workloads? And the way we do that is we have a feature called AutoStats where we put the statistics in TempDB associated with that database. So we don't have to change the physical characteristics of that user database while still being able to provide the right sets of statistics to optimize your indices. As the databases need to be physically consistent, if I need an index that's specific for my read workload, I'll actually need to create that index on the primary side, and it'll get transported over to the secondary side. But I can look at the statistics from what does the primary workload look like, the way that I've always done before, and I have this new DMV that'll show me the statistics on the secondary side that we store in TempDB to give you the ability to optimize for both those types of workloads. And there's a bunch more details in the deck that I'll leave for offline reading, or if any of you are interested in more details here, I'll more than happy to go through it with you on the booth. So I want to go through the disaster recovery scenario. And this will go through end-to-end failovers. How do I readjust quorum configurations? So let's say I have system up and running. So I've been running on server 2 and 3. I'm going to open up Server Manager, and I'm going to crash. Just turn off Server 2 and turn off Server 3. As these guys were the only two guys that had votes, my file share is still up and running, but the 2 votes went down. So I've lost 2 out of the 3 votes, and I'm going to see the Windows clusters are going to lose quorum. Say I now want to fail over to Server 4. I'm going to connect to the local cluster over here. See, it's going to take a bit and say, hey, I'm down. Yep. Oh, sorry. Yep. So now I see that the cluster's down. If I go look at my SMS window over here, let's take a look at the dashboard. Actually, refresh the dashboard. So let's see what's going on in the dashboard. Dashboard sometimes does little funky things when the cluster is down. Okay, I'm going to jump ahead. So basically, the dashboard's going to come back and say, since the cluster's lost quorum, my availability group is down, and I'm in a critical situation and I need to get things up and running. So first thing I'm going to do is I'm going to run force start the cluster in quorum. So I can do that from the UI, it gives me a little bit more protection, takes a little bit more time. It goes and makes sure, hey, can I find the cluster somewhere else? Maybe the admin didn't know what he was doing over here. Or I can run net start cluster service with FQ flag. I'll actually stop it since it's in the process of trying to talk to somebody else. If I go through if I went through the GUI, it would actually go through and try to figure out what's going on a little bit more. This will get it started a little bit faster. So what this did is it said, I don't care whether you have quorum or not. I'm going to tell you to go and run regardless. And run with whatever view of the information you had before. Now if let's close the connection over here. I'll go connect over here as well. So I can see it's giving me a warning over here. It says clusters running in forced quorum mode. This can result in a total loss of cluster configuration. It's basically saying I'm running with some version of the data. I don't know whether my view of who is synchronized and who's not synchronized is correct. So just want to give you a warning that you could be in a bad state. If my other two, server 2 and server 3, come online right now and talk to each other and don't talk to this guy, they have enough votes to form quorum. And so they'll continue to run. So I can easily get in a split brain scenario. So it's very careful when I go through that forced quorum thing that I know, hey, that site is down. I'm going to go and protect that site from coming online, and I'm going to operate over here. My next step is going to be, so I have the cluster up and running, but I don't have the availability group up and running. So my next step is going to be to go over to server 4. And I'm going to fail over the availability group onto server 4. And this is going to be the forced failover allow data loss. So I'm saying, even though he might have been synchronized at the time that I shut down server 2 and server 3, since I'm running with old cluster configuration, I can't know that for sure. I can't tell the difference as server 4, whether you forced, after the time that I split off from server 2 and server 3, that they actually continue to run, process transactions, and then they went and crashed and you told me to go and run. So I always have to run with data loss over here, or with giving the system the ability to go and choose that data loss. So now that I've done that, let's see what the dashboard looks like. So it's saying, hey, your primary is up and running. Your secondary is not. My next step is going to be, I need to go and adjust my quorum settings. So if I look at what quorum looks like right now, I still go and have my votes to server 2 and server 3. So I'm going to change this to say votes DR. Whoops. So what this did is I went through and I did that same evaluation. I said I'm right now have one primary. There's no automatic failover targets. So I changed my votes to say server 4 is the only one that has votes right now. And now if I look in the cluster, let me refresh this guy. It comes back and says, hey, you're running with node and file share majority again. I won't do this here since we're running out of time, but my next step would be to remove that file share. Now I'm back up and running with a normal cluster over here. Running with that one vote. If I bring the other systems, the server 2 and server 3 online, I want to bring them one at a time so they don't talk to each other because they still think that they both have the votes until they talk to this guy. I bring them online, they'll talk to the new cluster over here and say, oh, I don't have any votes anymore. And then I can go through and do the same thing as database mirroring, where I resume each one of the databases. So when each one of those things run after a forced failover, we'll suspend them because they may have data that I don't have on my side. So we want to make sure we give the opportunity for an admin to go query that data using readable secondaries. I can go now query the data, see are there transactions that I'm missing on the new primary, and decide how I want to reconcile that. Or I can go through, I won't start them up now because it's going to take a little bit of time, but I can show you how that would normally work. Or I can go through, I'd right click on the database and say, there'll be a thing that says resume, and I can choose each database independently to go and resume, and say get up and running over here. So that's basically it for the DR. Let's talk a little about what we could have gotten. I skipped out adding that additional secondary, but I now was able to go and take the database and log shipping configuration, move it to always on availability groups, got advantage of those better SLAs. Then I said, I'm going to take the backups and I don't want that to impact my primary system, so I offloaded that to a secondary system. Then I went and said I want to create another secondary. I could use those backups to go and see that secondary. We didn't actually see that today, but trust me, it can work. Then I go through the reporting workload. We saw a quick view of that through that application that I had, where I used read-only routing to connect to that primary, and it told me, hey, you're a read-only application. I'm going to go and offload you to the secondary, which gives me more capacity on my primary system to run my primary workloads. So I just showed you how to do this with direct attached storage, and then I mentioned in the beginning, each one of those instances could have been failover cluster instances and had shared storage. So I could have chosen to use in each one of the sites, I could have chosen my local high availability, could have been failover clustering with shared storage, give me that data protection, and then I could use availability groups between my data centers only and let failover clustering be the protection within a data center. And that works perfectly fine as well. So you get the flexibility of mixing and matching these solutions as and when you want them. And this goes through a quick summary of some of the features that I added. So by moving to always-on availability groups, I got the better SLAs. I was able to add more secondaries and use continuous replication across them. I was able to use that application virtual name to give me the abstraction to the clients of what does a backend topology look like. So as I increase complexity in the backend, I don't have to go and manage each one of the clients to go and update there. We saw a quick peek of that configuration wizard. Santosh showed a little bit more about how to create it end-to-end. You saw the dashboard that gives me that view of what's going on across the state of the system over here. Didn't see the system-centered integration, but we have rich system-centered integration over there. And we were able to take advantage of active secondaries to reduce the impact on the primary system. So I'll leave this in the deck, but there's a Denali Always-On Resource Center. This links to quick links to books, online articles for Always-On. Has links to the blog as well as CTP downloads. MSDN forums where we'll respond to questions. So this is a great place for any questions that you have after the conference and when you're playing around with the CTP that we have available for download there. As a link to Microsoft Connect, for any of you who don't know Microsoft Connect, great tool to provide feedback directly to the product team. Some feedback that we've heard is, hey, I go file this thing and somebody says, we'll take a look at this. And then I hear nothing back from it. To let you guys know that that actually goes into the same bug database that when I go file a bug against the product team or anybody else in the team files an issue, it goes into the same spot. So when we say, we'll get back to you, it doesn't just go into nowhere and it disappears forever. It actually gets tracked. We look through votes and we'll make decisions on what features to go and add based on the number of votes. We'll look at the sets of feedback and see what kinds of issues we have. So it may seem like it goes into nowhere land, but it actually does become a valuable tool for us. The Always-On blog, we'll start seeing more things that come up. So as we see questions and forums and conferences that are repeated, we'll look at the Always-On blog as a way of providing quick videos and other tutorials on quick topics there. There's also this afternoon, we have a panel discussion. I know I didn't get too much time to take questions here, but this afternoon we'll have all the Always-On PMs available for a question and answer session. I'll make sure I bring the demo laptop with me, so if there's anything that I missed or you want to go into a little bit more detail there, that we can dive right into those pieces. We have some interactive sessions and hands-on labs that are also great. And of course, the mission-critical booth for SQL Server will all be around and be able to walk through demos of this or talk through any of the details that I had to go through a little bit quickly in this session. Thank you all for attending. I'll stick around. I'll actually probably need to walk outside to let the next speaker come in, but I'll stick around outside if there's any questions that you have. And then I'll head over to the booth to be able to answer anything else there. Thank you very much.